asking is like, there's way too much here to do for in a lesson. So it's like, where do you guys want us to start? 2.3, 2.4, 2.5. What would be best to work on today to look at?
The 2.2.
2.2. All right, let me go see if I can find that. All right, these were scanned in reverse. There we go. Okay. 2.2, deductive reasoning.
Yeah.
You? Okay, great. And looks like you've done a couple of the questions here. Do you want us to start with number 4? Do you want me to start on the next page, number 5? What would be best for you?
On the next page.
Okay. All right. So let me now that I know where we're going to start here. We're going to go to about 9:25 and then give some feedback to dad, mom or dad if they're available. But let's take a look here at question number 5. All right. It says in exercises 5 and 6, make and test a conjecture about the given quantity. So you're supposed to provide sort of an answer to the sum of two negative integers is, and it's kind of like a fill in the blank. And to answer this, and this is where it's kind of odd because it's not like your other courses that you take in math, you almost want to just try something, try some numbers here, like -1 plus -2. What does that add up to?
-3.
-3. All right. -3 plus, -10, -13. And you're supposed to, like you saw in questions 1 through 4, you're supposed to sort of come up with a pattern. What do you notice about the answer? These answers. What could you say is the same about both of them?
They're both negative.
Yes. So we could say the sum of two negative integers is always negative. And that is always true. So they're looking for you to come up with some sort of a conclusion. And, testing it means you try to find some examples that you think make it work either always or sometimes or never, where this is kind of leading. All right, let's take a look at number 6 here. All right, the product of 3 consecutive non-zero integers. So 3 consecutive, what does that mean to you?
I don't know.
So what does something mean if it's consecutive or in order, we can say? Does that mean
the same over and over?
Okay, so that would be if they were the same, but consecutive means that they're one follows another. Like there's almost like an order to it or a leader. So for example, 1, 2, and 3 are consecutive non-zero integers. They're consecutive because one follows the next.
Okay.
Okay. Now, what is the math operation of product? What does that mean?
Multiplication.
Okay. And what do you know about the product here?
That it's 6.
Okay. All right. Now I want you to pick 3 other consecutive integers. Doesn't matter what they are, and do the same thing.
4, 5, 6.
Okay. What is the product of 4, 5, and 6?
Wouldn't it be 120?
It is 120. Okay. Now notice we're choosing positive integers, right? Integers are not positive. All right. So let's look at 3 consecutive negative integers. Okay. Like -2, -3, and -4. What is the product of these?
24.
Positive or negative?
Positive.
All right, so these two make positive, right? Negative, that's 6, but when you multiply that by the third negative, ends up being negative.
Yeah.
All right, so now what do you notice about the results? Like when you multiply 3 positives, the answer is positive. 3 negatives, the answer is
Negative.
negative. So can you draw any conclusions about the product of 3 consecutive integers? Like, do you know that it is always positive, always negative?
Um, um, yeah.
All right, so this is the dynamic part of the lesson where I'm trying to get you to give me some feedback. Like, what can you say that it's always positive or always negative, or what's the issue there?
Um, can it be both?
It can be both. It can be both. So the problem is we can't say that it's always positive or always negative. So the conclusion is that, well, it's either positive or negative. Any questions on that before we proceed to another problem?
Um, can you explain the difference between like the first three consecutive and then the negative ones?
So what we're trying to do here, and I think that one of the issues here is that we're trying to like build something out of a problem that really isn't there. Like they're just trying to get you to work through some examples and see, um, does it like can you always draw a conclusion? Um, like let's use something totally different. If there are clouds in the sky, okay, what's possible when there are clouds in the sky in terms of
That is,
weather? What might happen?
it might rain.
It might rain, but does it always rain?
No.
No, no rain. Like it could be, all right, but there are situations where it always leads to like something. And that's what that like the math ones are the better ones. Like because if you say like adding two negative integers, well, you always you always get a negative. But there are problems where you sometimes get one thing and sometimes you get another. And that's the whole point here. Now, this 3 consecutive integers stuff, they're hoping that you only do the positives, but you have to generally do like both positive, both negative. You kind of got to work through all the cases.
Okay.
All right, let's try number 7 here. This is more logic. I mean, this isn't really geometry, truthfully. This is more of a what you see in a logic or a proofs class, but they kind of throw it in here. And you're probably figuring out there's a lot of vocabulary, a lot of vocabulary. So, all right. If n is a rational number, okay, any idea what the word rational means?
No.
Okay, so a rational number can be written as a fraction. So for example, 1/2 is a rational number, but so is 8. And you might be like, well, eight's not a fraction. I'm like, you're right, because you can write it as 8 over 1.
Okay.
All right. So a rational number is a fraction, or it could be a number, but it can be always be written as a fraction. Okay.
Mhm.
Now they're saying then if a number is a rational number, like these are your examples of rational numbers, then n squared is always less than n. Okay. So basically we're trying to decide, is this always true? Well, let's do it for each of these examples. Let's say that n is 1/2. What is n squared? Well, it's 1/2 squared, which is 1/4. Is n squared 1/4 less than 1/2? Is this true or false?
That's true.
This one's true. That's good. Now, we don't have enough to know if that's always true, so let's try the next one. Let's say n is 8. Well, n squared is 8 squared, which is 64. Is 64 less than 8?
No.
No. So can we say that it's always true? No. And that's why it says here to find a counterexample. It says, find something that doesn't work.
Yeah.
And, depending on your comfort level, you have to kind of like look at all the cases and see if you can find one that does or doesn't work. Um, that could be the challenge. So uh, let's keep going here. Any feedback for me? I mean, is this helping? Is it, I mean, do you feel like you're, I want to make sure you're getting the most out of this time we've got. Do you want us to keep going through 2.2 or do you want us to go on to another section?
Well, 2.2 is my homework for tonight. Like, I don't have to
Okay.
finish the whole packet, but she's checking this section tomorrow.
Okay. All right. Another kind of challenge with geometry is it's very visual. So you maybe need to like almost see stuff in the classroom or have some examples of things. So it says line K intersects plane P. So a plane, the best way to draw a plane is kind of like as a sheet of paper. So if you have a sheet of paper and you hold it up, but it extends infinitely in all directions. Hopefully you've been given that or told that in class. Is that
Um,
okay?
yeah.
Okay. So line K intersects plane P at point Q on the plane. So no, I don't really have any, this would be a really good visual, but imagine a sheet of paper and then like your pen or pencil kind of coming down, hitting the plane, but then it goes through the other side. Okay. That's line K. Line K is there. Maybe that's, it's going through somewhere in the plane, right? Like that. The question is are these perpendicular? Like, is that the only possibility? Like, it comes straight down, hit the plane, go straight down. Is that the only possibility? And you might think, well, yeah, that's the only possibility. So you've got to just be more creative with options. Like, it could be coming at an angle, and then it hits, goes through like that. So it only hits at one place, but this angle right here is not 90 degrees. You can imagine your pen coming at an angle or pencil coming at an angle into the sheet of paper, potentially. Yes, no, maybe.
Yeah.
Is that, I mean, I can jump on camera and show you this with, piece of paper and a pencil, but hopefully this is sufficient for you.
Yeah, it is.
Okay, let's keep going here. All right. Number nine. Okay, in exercises 9 and 10, use the law of detachment to determine what you can conclude from the given information if possible. So, do you have in your notes what the law of detachment is?
Mm, no.
Okay. Um, did you guys talk about like if P then Q in class?
No.
All right. Seems like you're missing some things to be able to do this, but that's okay. We can still do it. I just sort of asking some questions. Now, is this due tomorrow? Is that what you're saying?
Yeah.
Okay. Does your teacher normally not cover everything that's required to do the homework?
Sometimes. No.
All right, that can be pretty frustrating. All right. Um, so in your book, maybe you're supposed to go and look and see, see what this is. Did you guys do any sort of truth tables? P, Q, P then Q, anything like that?
No.
Oh my gosh. Okay. Well, that makes this tough to do. All right. All right. We'll just reset here. All right. So we'll just look at the statement. If a triangle has equal side lengths, okay, so here's a triangle, equal side lengths. then then each interior angle measure is 60 degrees. So you'll learn this later in the course, but if all sides are the same, maybe you already got this, then all angles are the same. Okay. And if all angles are the same, because they have to add up to 180, they are all 60 degrees. Okay. Um, so the question is, can you conclude from the given information? Like, are you allowed to conclude that this is true? If this is true, then this is true. And that's where I've got to go back to what you didn't see in class, which I don't understand how they can have you do it this way. But um, you sure you don't have any notes on this?
No, I don't have any.
Okay. All right. All right. So the way this works, um, I'm trying to decide a best way to proceed here. If we should go through the logic. So it works like this. If key is true, and key is this what's called this first part here, without getting into it's the first part, first clause, basically. If that is true, so we assume that it's true. If all the sides are the same, we can then assume that Q is true. Q is this next part after the then. So there's a P and then there's this Q. Like this is what the law of detachment says. It says if you assume the first part is true, then the second part must be true. Okay. But there's also other things like you can assume that the first part is not true. Then what does that mean for the second part? And if you assume that the second part is true, what does that mean for the first part? So I'm not really sure how to tell you how to answer this because I don't know what you guys are talking about in the classroom, but you can say that uh, this is true. And this is an equilateral triangle because all the sides are the same, all the angles are the same. Any thoughts on that?
No.
Okay. So 10 is more problematic. So 10 is more problematic because it says if a quadrilateral is a rhombus. So that's your first part. And I don't know how much you've gone into this, but quadrilateral means it has four sides. Rhombus means that all the sides are congruent. So these are all congruent. Then it has two pairs of opposite sides that are parallel. That means that this is parallel to this, top is parallel to bottom, left is parallel to the right. Okay. And that's all true. That's all good and true. But then it says in the second sense, there's quadrilateral PQRS. It's two pairs of opposite sides that are parallel. So the problem here is that in this next example, PQ, R, and S, these can be parallel, but it doesn't mean that they're all congruent. And the way I've drawn it, you can see that very clearly. The top and the bottom are longer than the right and the left. So the problem here is that it does not follow in this second example here that this is true. Like it's not a guarantee that PQRS is not a rhombus. Even though it has two pairs of opposite sides that are parallel, like it has that, but we don't know if they're not congruent, then it's not a rhombus. A rhombus requires all sides to be congruent. So this has the problem, like this is now if Q is true, which is the second part, it does not mean that P is true. P is the fact that it would be a rhombus. Like it could be, but it couldn't be. I know maybe that's not great to hear because it's not specific, but this proofs and logic are a little bit more they're different to dissect. They're not just like solving for X. There's a little more gray in them. They're more like art, truthfully. Okay, I'm going to stop the recording